Okay. I'd like to thank, does anybody see Dave Hussman in the previous session? That was really good. And he's still the coolest guy in the business. This is his T-shirt. So the talk is a bit about the purpose of test-driven and sort of the motivations for it, and some examples, a little bit of code, and some sort of thoughts about why it might work. And I know it's been a long day, so I'll try not to be too boring, at least for the day. So, how many people are familiar with the hype curve? Have you seen this one? So, yeah, I've been through a number of these. One of these for OO, and one of these for client server, and top-down structural decomposition. Does anyone remember that one? Yes. It's pretty much the same. You know, pioneering, hype, exploitation, and backlash. I've been on stuff where we've gone straight from obscurity to backlash, and without the nice bit in the middle. And I kind of figure test-driven is kind of about there at the moment. A little while ago, there was a whole sort of burst of activity about how test-driven was dead and never worked in the first place. And then a number of people wrote responding talks. And so I'm kind of hoping we're going to go back up to the plateau of productivity eventually. And part of it is about, because the ideas are very simple, but like a lot of simple ideas, there are subtleties in practice that do take time to learn. And there are fundamentals that are easy to lose sight of with all the noise. It's worth revisiting from time to time. And that's pretty much what this is, some of what this is about. We've come a long way. It's actually about 15 years, so maybe slightly longer, depends on what you think. Testing used to be this low status occupation that was trapped at the back of the process, and usually got squashed because everything else ran late. The real ninja rock stars were the developers who designed frameworks for lesser developers to use to build applications for testers to test. That was also a time when we drove without seatbelts and used to smoke indoors. As far as I can tell them, yeah. But nowadays, of course, everybody takes testing seriously. It's quite for those of you who haven't been through this cycle, it's quite a shift. And I still meet people who don't really, a few people that don't really go for this. Some developers have even become concerned whether their designs are testable, and a smaller number are even prepared to refactor their code to make it so. So first, a little recap, just in case you've forgotten since 10 minutes ago. Here's the cycle. You add a little test, run all the tests, watch it fail, make sure it does actually fail. Make a little change, run all the tests, watch them succeed. And then from time to time, you notice duplication and a bit of crud in the, not crud, technical debt. How many people saw the Dot Norton? Yeah, right. I'm trying to get that right. Maybe crud is the right word. But anyway, the point being is you refactor to clean up and remove duplication. And the heuristics are, the sort of the hardcore version is you only write code if you've got new code if you've got failing test. And that's, if you like, that's your analysis moment. That's when you decide what the next feature is going to be and how you're going to trigger it. So you also have to think about the API. And the design moment is from time to time you notice the duplication and you refactor a bit. And it's simple, but that's not all of it. Not everybody agrees that this nice picture, or this picture. Some people find that after a while they've got this shadow code base that doesn't help them understand the code, has never caught a critical bug, and every time they try and change anything, it all goes bang and they have to fix it. And usually what happens after a while is, of course, they start turning it off or delete. No, people haven't quite got the confidence to actually delete it, which would be the right thing, delete the tests. But certainly you come across this from time to time. And if you don't believe me, here's a real example. You don't have to read this, though, or maybe you should. There'll be a test afterwards. It's kind of like a bit of a semi-integration test. In case you're wondering, this is all the mock setup, and that's the test. Now, I should point out, this is real code off a project I got invited, and these guys are pals of mine, and they're still pretty good friends. They're all, I mean, they were, a clever bunch of people, all went to good schools and the rest of it. In fact, if they hadn't been so clever, this whole project would have collapsed much earlier. It was a sign of their cleverness, how long they could keep this thing going. And there were, this is just one. There was a whole bunch of these. And the problem was that they sort of got the gestures, but they hadn't really understood the machinery in depth, if you like. You can't see it, but it took a while before someone noticed that in this there is a field of type God object with a mock God, which was interesting. And the happy ending is that we did actually clean this up, and everything got much better in the end, but it took a while. One way of describing these is I can't remember who did this. This came up with called these MD5 tests. You can show that prove that the code hasn't changed, but you have no idea what this test means. And you get these sort of qualities to sort of bad test suites. They're inexpressive. The tests are mostly concerned with asserting detail. They don't tell you what the point is. They tend to be overspecified, so lots of assertions about lots of detail everywhere throughout in all possible places. So it's very hard to tell which things really matter in a particular place or which things are just sort of incidental. Sometimes you see tests that are too clever, particularly in the VM worlds. You sometimes get people using frameworks that will sort of do reflecto magic to get around the barriers of the design that they're working with. And then what that does is it binds the test deeply into the implementation and makes everything brittle, which is, again, if you've got if your coupling is too tight to the current implementation, when the implementation changes in a way that doesn't matter, everything breaks. And then one final thing, which is if you don't pay attention to the failures, then when failures happen, it's hard to tell whether what you see is just something accidental and doesn't really matter, or whether it's actually something significant that's gone wrong. And so reporting correctly or reporting helpfully is the sort of thing that tends to get ignored. How do you get into this world? Well, this is a colleague of mine. This is the test driven as observed in the field. There's a colleague called Keith Braithwaite. He says the way you do it is you think up a design, you write some tests that assert the design exists, implement a bunch of stuff, test debug, because it doesn't work, obviously. Test debug, test debug. Eventually it works. You write some to-dos to go back and refactor stuff later and carry on. And again, this is how you accrue technical debt at a rate of knots, or whatever the metric is. Incidentally, Keith asked me to put this warning sign, the warning symbol, on the slide to make it clear that when this is snapped and stuck on the internet, he's not endorsing this as a process. It's supposed to be a bad thing. And I think what this is part of is what you might call, what I sort of call test-driven theatre. If you're familiar with the term security theatre, has somebody heard this one? Good. This is a very important chap in IT security called Bruce Schneier. Came up with this notion of security theatre, which is the sort of thing you do when you want to show that you're making an effort. So you do some stuff, and whether it works or not is not quite clear. And good examples of this are things like some of the sort of password restrictions you get, which actually don't help make passwords more. It just means you write them down so that they can be found. And I have a friend actually in London who does social aspects of security, who has a lot of good material on this kind of stuff. She once got invited to a PGP, do I mean PGP? PGP conference. He says, well, I don't know anything about encryption. He says, no, we can do an encryption, we just don't know how to distribute the keys. Which is an interesting question. Anyway, so the point being about this is that it's the sort of thing you do when you want to be doing the right thing, and you want to be seen to be doing the right thing, but you're not quite sure what to do, so you do something, and it turns out to be very expensive and just make everyone's life just that little bit more difficult. So if these are like the failures, what does success look like? Let's pretend for a moment, imagine that we actually believe in some of this stuff. What should effective TDD feel like? Well, what are the tests for test-driven development, if you like? And I've got sort of about 4 or 5 qualities that to me feel right. One is you're making steady incremental progress. Add a feature at a time, and you either change functionality or improve the design. You're not constantly reworking the test to get them to work. You should be avoiding debug hell. My worst bug ever took 3 weeks to find. Multi-threaded C++. I managed to crash Solaris. I don't ever want to go there again. It was horrible. And so, you get this steady flow. It's another Ward Cunningham line, which is that when you're doing XP well, and I kind of use the two sort of a little bit interchangeably, it seems like you're not going very fast. It's very deliberate, because everything's been done very carefully. But it just keeps moving. It's just relentless. In fact, there is a failure mode with really high-performing XP teams, which they get bored, because all they're doing is shipping features and making money, or whatever. You hope they're making money, and it's really boring after a while. And then you have to sort of start adding some entertainment or something. Anyway, the other thing that I think is unappreciated by a lot of people is this constant positive reinforcement. Is you're only ever this far away from something that works. You're constantly succeeding. And if you're feeling a bit low, you can hit the button a few times and get some green bars, get your buzz. And you don't get you avoid the emotional cost of what I might call boom and bust coding, which I used to do. Put the headphones on, get into the zone, stay up late, It's great, you feel fantastic, and then you come down. And then you've got this stuff that you lost control of, it's broken in some way you can't understand. I had many years ago, one of my first XP projects, I had one of the guys who just wasn't going to play. And so we found him a special project. And I remember after a while sort of looking over, and he was just slumped in his chair, miserable because he'd got a memory smash or something. I'm thinking, I haven't had that in a while. That's interesting. I think before I code, I think this is quite, again, it's this thing about declaring what I want to happen before I start thinking about the implementation, because it's so easy to jump into the implementation. And I think about this from the point of view of the caller, which just helps to drive out my assumptions at kind of all levels. And I know this is working really well when we're about to write a test and we don't understand what we need to do, and we have to go and ask a domain expert. Things break when they're supposed to. So one of the regular complaints you get with some of the test-driven stuff is, I make this little change and everything breaks, and it's just really tedious. But actually, the tests are doing their job. They're telling you that there are too many dependencies. You haven't actually cleaned up the code. You have crud. And you haven't really teased out your dependencies. And again, many teams respond to this by just sort of turning it all off, when actually what they should be doing is taking the time to figure out why everything is so interlinked. And finally in this section, and this is a great surprise, speaking as a deeply pathological control freak, it took me a long time to learn to relax my need to predict what I needed and learn to follow the code. And I regularly find that this produces a better, as in simpler design than the one I thought I was going to. I was absolutely convinced I was going to need. And a lot of this is about learning to wait for evidence that a structure is needed, rather than coding it up speculatively. This really cool thing, you've got closures, and actually you don't need it. And sometimes the way it happens is that you get a concept, you're cleaning up the tests to make it a bit more explanatory, and a concept pops up, and you realize, oh, that's a really interesting concept, and it drifts across to production. It migrates across to production. It doesn't happen very often, but it's nice when it does. There is a corollary to this, which is that all of this stuff only works if the team has time to follow the refactorings when they appear, and to clean up and to restructure as as the insights happen. If you're on a feature treadmill, you know, you feature, then you just end up with an incremental mess. So this is, again, one of those conditions that not every team is able to follow. So we know what the bad stuff looks like. We know what it's supposed to look like. How do you do it? How do you do it well? How do we get some of those meta tests to pass? And I'll just pick 3 techniques. There's loads of material on this, but I'll just pick 3 tests for now. One is when you're lost, slow down, testing at the right level, which if you were in the previous talk here, there'd be some of, and then writing readable code. So when you're lost, slow down. This is one of the surprising things that came out of this. So Kent wrote this book partly in public on the web at the time. And one of the things that nobody really thought of, or hadn't been, it's kind of appeared as he was working on this, was that there are times when you really don't know what to do next. And the trick is to turn the dial all the way down. Rather than going up to 11, is turn it down to like 0.1 or something. And take tiny, tiny steps, do kind of really obvious, stupid things. Because what you find is that when you don't know where you're going, if you take tiny little steps, you can just sort of explore the space, and then suddenly you realize, oh, that's what it meant. And then that takes you into a new space, and you can turn the dial back up. And you won't do this every day, but it's a really useful thing to have in your toolbox sometimes. Testing at the right level. So in our world, we quite often like to start a piece of work with an end-to-end test to show what we're trying to achieve. And you know, all of this, it could be in this world. These pictures tend to talk, describe monoliths, but there's no reason that they couldn't be clusters of applications, maybe even lots of little microservices. But that's not the whole picture. Many teams do the bulk of their testing completely from the outside. And you need a few of these because it shows that things hang together. But unless you're extremely lucky, it doesn't scale. It tends to be slow and brittle and hard to interpret the results. You know, you run your tests, it takes a while, then one of them goes red, and what happened? The computer goes, well, I'm not going to tell you. And then you're then sort of stuck in a long session of debugging and tracing and stuff because you forgot to put all the tracing in and the correlations in. What you need to be doing is having the trust that you're building on reliable components. Just a brief interlude. This is our picture of ports and adapters architecture. The model is that the idea is that in the middle is your nice clean model, everything done very cleanly. And then at some point you have to deal with the world that's full of nasty things like databases and people. How do you deal with those is you define what you need from the outside world through what are called ports, and then you write adapters that are as thin as possible to get you from one to the other. And if you do that structure, you can do a lot of your acceptance testing through the ports. And that gives you, it demonstrates the functionality without spinning up the whole thing. And it can make the equivalent to the end-to-end testing, the acceptance testing going really much faster, and you get much better feedback. That begs the question, how do you know the adapters work? Well, we can test those separately, because this is usually an integration problem. There's usually very little code in here that's not worth unit testing. But your database tables are moved or something like that. And the nice thing about this is you can make nice focused tests that exercise all the edge cases without bringing up the whole system. And if you put it at the front of your build pipeline, you can stop and not spin up the whole thing if it turns out that this bit is wrong. And then finally, there's unit testing. And this is the bit that all the books talk about. And this is the bit that everybody teaches. And you can see that it's actually not, it's only part of a whole. One of the things I have found, actually, is that this ports and adapters pattern in a code base of any size is fractal. It's quite often you'll get subsections of the code that really ought to be structured as ports and adapters. And one of the things that you look for in a code base of a reasonable size is that if you find that all your tests are either production or system level or unit level, there are some intermediate levels that are missing. That's a bit of a clue. And the third thing in this section, when we write code that describes what we want, So here's a test I don't like very much. It's got a number of features about it. It's got, some people recommend this sort of style where you put the method under test in the name of the test. And I don't like that for a number of reasons I'll explain. One of which is I've got a perfectly good editor here, and I can see that we're calling add. I don't need to say that twice. But it doesn't tell me. It tells me that I'm adding an item, and what does that mean? I don't really know. It breaks encapsulation, so there's a little bit of magic in here. And it's actually quite obvious if you notice it, because at the top we're talking about baskets and items, and all of a sudden we're talking about backdoors and item lists and things, and there's a shift in vocabulary. It's like any code. You want a consistency of a vocabulary within a unit of code. But the main thing is that there's no intent. It doesn't really tell you what the point is. It just tells you, well, I can assert that this thing gets added and that some secret thing inside hangs onto it. So I quite like this style. It's called test docs. It's first written up by Chris Stevenson. And the premise is that you make the thing under test the subject of a sentence. I don't know if it works in other languages. It works in English. So what is a basket? Well, what do we know about a basket? A basket is empty when it's created. A basket returns items in the order they were added. Basket tells, you get the point. And you get this nice little summary description of things that you need to know about a basket. And I find it's a good discipline. I find if I can't write that little sentence, then I don't know what the next feature is going to be. Other people like to go the other way. What else? We're going through the public API. So no magic, no secret reflector magic. If I need to access something inside, if I'm trying to write this test and there's no visible effect that tells me that it's worked, that's another one of those little design moments that tells me it's time to change the code because something's going on that I can't see. So you'll see that that's all public API. Protocols, not interfaces. There's a slight confusion because some languages use protocols, use the term protocols for interfaces and vice versa. Interfaces tell you, I can't remember who I heard it from, interfaces tell you whether two objects will fit together, but they don't tell you how they work together. Protocols is how you work with those methods, with that interface. Because the thing is, I'm not testing methods, I'm testing objects. And so if we look at the example, we look at the second one. What it says is I'm returning items in the order they were added. That's a relationship. I'm not testing the adder or the sequence method. I'm testing that relationship. Sorry. Okay. Sorry, we knocked off balance there. And then the final one in this little section is from the simple to the complicated, and this should be standard thing. Start from the simplest idea, and then grow the implementation from there. And this works at all levels. I mean, at the system level, it's called a walking skeleton. Here's a sort of little case. Here, you start with an empty basket, and then you know it can hold some items, and then you know it can sum up the cost of the items, and then you do some failure cases. There's some interesting discussion around people doing property-based testing at this sort of incrementally. And I haven't done much of it. The people I know that have been working on it, it looks like it goes in the opposite direction, is that when you're doing example-based testing, you start with the simplest possible thing that does one thing, and then you grow from there. Whereas the property-based stuff is you start from the weakest constraint. So sort of you start with an object that could do anything, and then you slowly converge it down to the thing that you actually want it to achieve. I think there's some very interesting potential stuff around there. I'd be really interested if anyone's actually made some progress. But actually, in either case, whatever techniques you're using, this is, again, another colleague of mine, it's about explaining the domain, not about proving the correctness of the code. And then if you want to write code you can live with, this is a nice one from Dale Emery, half of the art of test automation is about making the test code sensitive to things you care about and insensitive to things you don't care about. And a lot of the pain and misery I see is because they're not taking care of this. So this is supposed to be a design. actually it's based in, I noticed it's based in Ontario, so this is probably Big Dave's house at some point. Testability is a design hint. And this is a thing that I'm sort of very strong on. And again, it's learning to understand this sort of feedback. And in the meta test, there was a thing about designs emerging from the process. So let's just look at a little example and see where it goes. So this is standard issue Java web code. Anybody got one of these? Yeah. And particularly, I want to talk, for the moment, about logging and reporting. And you see this is very common, that the logging is interleaved with the code. This sort of stuff I have problems with. One is that there's a mix of, that the concerns are all mixed up, sort of all mixed up together. And what we're doing is we're writing strings out to this stream. So all our error messages are, or our reporting is effectively stringly typed. And I have never yet met a team that can do this consistently because it's just too much effort. But logs are actually quite important. If you actually go to support anything, this is your UI for support. And how do we know which messages matter? How do we know which messages are going to be scraped and then some important signal or whatever is going to fire off them? So, which means I can't change it without getting somebody upset. Oh, and then finally there's the one at the bottom, the log error and then rethrow. That basically means I have no idea what to do when this happens. I know I'll log it and then rethrow it for someone else to take care of. And we know what happens the next level up, same again. And the next level up, same again. And you end up with hundreds of lines of the same stack trace all over again, when none of which is useful information. It's just noise that gets in the way of the information you actually want. The relevance to this bit, there is actually some relevance, is it's also very hard to test. If you care about what gets written out what events get written down, this is a right pain to test in a unit test because log is a singleton. You haven't got a unit test here anymore. You've got like a little integration system test because you've got this singleton you don't control. And it's really, you know, there are obviously things you can do, but it's just painful and noisy and not much fun. So if we kind of respond to that, what is, you know, that design stress? What could we do? Well, maybe we could back off and we could actually introduce an object to represent, or a collaborator to represent this behavior, like a monitor or a listener or something like that. And at this point, I mean, there are different ways of doing this. So that at this point, we're starting to introduce a little bit of semantics, and we're actually introducing events, structured events, if you like, into this little bit of code. We ditched the try-catch rethrow because that was a bad idea in the first place. But this is really easy to test because you can introduce a nice little mock for your monitor and get the job done. And it is actually a unit test, unlike the previous example. What the monitor actually does is not the concern of this bit of code, because it might actually write a log or it might do something else altogether. Who knows? So this is obviously not, what I've just shown you is not a test-driven sequence, but you can imagine approaching this. I'm writing this bit of web code, and I want to know what's happened. I know I'll introduce a monitor. So having made that separation, that opens up more possibilities. It might be that what we actually do is write these events out to some kind of message bus. And then different resources can pick them up. We might use it for real-time monitoring. We might actually write a log. Or we might do something clever and self-healing, whatever. It's not our concern. We can let the system decide what to do. And then within this infrastructure, the same thing happens at the system level. With this infrastructure in place, the system-level testing gets easier. System-level testing where you're looking for log messages, again, it's really painful because you need access to the file system and you need, you know, is it buffered, and then you need timeouts and delays, and it's just deeply unpleasant. If you know that specific events are being fired off over some nice bit of machinery, that makes it much easier to track what's going on in the test. And this gets us into another feedback loop, which is I'm about to write a test for some kind of new feature, but I can't see what's happening in the system that will tell me that this particular activity has happened. And I go, oh, I need a new event. I need to create a new event type. And then I can push that through into the code. And part of the motivation for this, or the theory behind this, or the fantasy behind this, is that the sort of things that you need to be able to do this kind of testing nicely tend to be the sort of things you need to know about in production. So in fact, you're sort of preparing for what you often find is that these sort of event types are the sort of things that you need to support the system. So here's a little example. It's not a very appropriate picture, but anyway. Let's say we want to do something, write some tests against something that involves a transaction and make sure it succeeds. One option is we run this thing and then we just wait a while and make sure that there are no error messages. And that's slow and painful and blah, 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 blah. Alternative might be, well, let's introduce an end of transaction event, and then our test can go, oh, end of transaction, I'm done. And it means it's also nice because you can partition things up and run tests in parallel. The whole thing just gets a lot more flexible. Maybe this turns out to be useful in production because if you want to bring the service down cleanly, you can monitor, shut off the input stream, wait for all the end of transaction events, and then you can shut it down because you know the system is idle. And again, it's a nice little. It is actually the team that did this actually did it in production. They actually found that this happened, and it's a way of thinking about using feedback from the activity of writing tests to help you think about the structure of the code and the system. So, I was running out of pictures at this point. Why might TTD work? And I wanted to think about the underlying principles of why it works for me, at least, on the grounds that if we understand those, or have a view on those, then we stand a better chance of making it work successfully and passing our meta tests. And for me, these are the sort of three things that do it. And for those of you who were in the Dave Farley's keynote yesterday, I'm assuming it's the same one, the one about engineering. These are three that are included in his list of what the qualities that make up engineering. Focused. One thing at a time, reliably. Either adding functionality or improving the code. I always find that even on a small scale, when I try and do the two together, I just get lost and have to roll back. And again, part of this is making me stop and think about what I actually need, not the solution that I just absolutely know that I need. And again, one of the problems that we have is that we're experts in implementation. And we keep thinking about, yeah, I know we can do this, and I can use a KD tree, and it'll be fantastic. You know, and actually, no, it's really simple. Just put a list in. And it's very hard to break that training. And just putting this little bit of grit, this little pause before you push ahead, I find really helps me just focus on not run away with my fantasies. Like I say, I've become very wary of the whole get into the flow thing, because it's just too easy to get in the buzz and not actually necessarily do anything useful. It feels great, have a great time, and then the best thing to do is bin it. How many people have ever seen a paper tape? There's a few of us left. The reason I've got this up is I was having an exchange with Kim Beck about some of these origin stories, and he tells this story about how, because his dad was a programmer, he's a second-generation programmer, and he came up with this story. So he read a book, and it said that the way to program is to look at the input tape, manually type in the output tape that you expect, and then you program until the actual expected tapes match, and you can sort of hold them up to the light and see if the holes line up. Incidentally, I'm going to talk about metaphors. The Cambridge EDSAC was one of the first stored program computers. The job queue was a washing line. You hung your tapes on the washing line, and there we go. Anyway, never mind that. And then I thought, what a stupid idea. I want tests that pass, not tests that fail. Why would I write a test when I'm sure it would fail? Well, I'm in the habit of trying stupid things out just to see what happens, so I tried it and it worked great. And this is the kicker for me, is I was finally able to separate logical from physical design. I'd always been told to do that, but no one ever explained how. And I found this a very useful way of thinking about the test is the logical design, the code is the physical design. And when you think about that, thinking that way, then that sort of pushes you towards writing tests that actually mean something, rather than just an accidental assertion across whatever implementation you have today that's going to change tomorrow. And with perfect timing, this came out last week, I think. A lot of this is really about coping with complexity, partitioning so that you can complexity. And this whole XP ecosystem stuff is about, so I can focus on one thing at a time and be safe to make changes and get on with things without worrying about bringing the world down around me. And again, remember a while ago I found this web page on this describing something about adult attention deficit disorder, which I hadn't realized this is a special condition, and all these practices that you do to cope with it. And I'm looking at it going, that's XP. And I sent a note to Kent, he says, yeah, well, mate, you might be right. Okay, 1. 2, it's concrete. So one of the things we've learned over sort of about psychology and brain working things is that people are much better at thinking in terms of examples than abstractions. One of the things we forget in this room is just how weird computational thinking is. Many of us, I suspect, have partners who we annoy intensely by all our careful algorithmic stuff, and it just doesn't make sense to them. And also in Western philosophy, like there's this school, I believe, goes back to Plato, which says, thinking in terms of objects in the room in relation to some ideal object. And you can see the sort of the mathematical origins of that as well. So you talk about this ideal table when actually it's very difficult to actually, when you start to look at it, it's very difficult to define what a table actually is. What we're good at is we're pattern matchers. This is how kids learn language, is you don't sit there and give them the dictionary definition when they're 3 or 2 or whatever. You say table, 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 and eventually they get the idea. And that's, we carry on doing this. Now, in the kind of software that most of the software I work on, it's kind of, that's what it's like. Working with examples is easier and safer than working with a formal spec. And I'll come back to that briefly in a second. Deep breath, it's okay, don't worry. We don't have to read all of this. This is an example from a project I worked on quite a while ago. It's actually a system for bonds, and the line is that bonds is like organic chemistry for finance. It's just full of stuff you have to remember that doesn't really make sense. And this is actually another award coming up special. It's a tool called Fit. And the idea is it takes web pages and you write a backing thing to interpret the web page, and then you generate an output, and the white bits are the inputs, and the green bits are the successful matches. And the reason I include this is because one of the things about each of those is an example of some exotic case that just kind of grew over the years. And what you find is when you're dealing with like normal people, you can show them this, and they go, "Yeah, but you missed that case where if there's the second is a Thursday and there's the moon is ascendant in whatever, then that's what it's called." Because people are good at recognizing that, and they're really bad at, on the whole, at sort of coming up with perfect rules. Is this suitable for algorithmic work, if you like? Probably not. That's the sort of thing where you do sit in your hammock and you think very carefully, and then eventually you figure out what to do and you type it in. But this sort of stuff is not like, there is no clean model for this stuff that you can do. And as I'm saying this, I'm wondering if that's one part of the divide between example-based and property-based testing. It's the property-based testing works when you have, maybe it works better. It's a speculation. It works better when you have a clean model, and this stuff works better when you're dealing with real-world crud. The story that made me more confident about this is a team we had, and as developers, we more or less forced it on the analysts. They didn't like it for a while, but they turned eventually, and we knew we'd made it when we got a new analyst, and he looked at all these web pages and went, "No, I'm not having that." And he went back to the old spec, and the spec is, it's just the party of the first part should be known as the party of the first part, and all this kind of stuff. And the system shall be easy to use and configurable. What does that mean? I don't know what that means. And he looked at that, and he came back to us. Because what he found with this was that he could take this and talk a domain expert through it. And they go, yeah, but you forgot this extra line. They could type it in, and they would see if it worked or not. If it worked, then we were done. So it's, and again, it's that thing about working with examples and pushing that through the system. And then finally, in this bit, I like it because it's empirical. It's full of questions like, does this work? If this worked, how would I know? That's the fundamental question in test-driven is, if this worked, how would I know? And that's your design moment. Let's go back to the loop. It's feedback. It's the feedback of writing a failing test and then making it pass. It's the feedback of trying to write a test and realizing you don't know what you're doing and escalating up a level. It's the feedback of trying to understand a requirement and not knowing what the purpose is and having to escalate that up to someone more important. And it's the feedback of trying to write at the code level, trying to write a test and realizing that the code is in the wrong shape, so you need to refactor. And the feedback of seeing the duplication, the actual duplication, and then extracting the structure. And it is, and Josh's book is still, I guess, the authorized version on this. So to finish, there is a finish to this. It's all about feedback. It's all about listening to what's going on. And as I was talking about this material with Gregor before he rushed off to Sydney, and he came with this really nice line, which is, if you think about the act of testing as creating signal, and then you can respond to it. And I find, again, this is not something I've thought of before, but it's a really nice way of looking at a lot of this thing. You're probing the system, trying to get it to respond. And I think what I see in a lot of, you can't actually see it, but there's a little circle on the top right. That's your basic TDD loop. That's what everybody teaches. That's what all the books are about, because that's easy to teach. I mean, there's stuff. But actually, there's all this other stuff going on. And I've always sort of, even from the beginning, we kind of thought of it in terms of these onion rings. It's all about feedback loops, because part of things like, we learn about the domain from trying to implement it. You get to the end of the project and you look at the structure and you go, that's what it should have been, but the project's over now, so you have to move on. You recognize this, right? That was a better line than I thought it was. And in many organizations, what happens is that understanding is buried in the development, deep in some junior programmer's head or something. And it either gets lost or evaporates or whatever. And traditionally, when all this stuff started up, I won't claim credit for that, is those barriers, those feedback barriers, tended to be around silos and handovers, and there were probably a couple of contract boundaries and a continent in the way. It wasn't going to happen. And then we had this thing where actually it's the whole team, and one of the things I'm fearing now is what I'm seeing, or might be seeing, is you get modern organizations and you've got your scrums and all the rest of it. But it's kind of turned into this feature factory where the developers sit there and go, what should I type? What would you like from a feature? Yeah, I'll give you a feature. And that whole discussion has gone because we've become so concerned about, rightly concerned about, business value and customer this, that, and the other, that we've forgotten that we're players in the game as well. And in fact, one of the lines you have to use with a lot of teams is that the development team itself is a stakeholder in the system that they're building, and we often forget that and we pay the price. And to me, there should be a continuum of experience from the smallest little cluster of classes all the way up to the purpose of the organization. So just to finish on a little story. So I think it's my second XP project, and it was a little team, and we had a product manager in those days. We didn't have product owners, we had product managers. And traditionally what would happen is the product manager would turn up to the team and go, got this great idea, it'll be fantastic. Can you do this? And the team was, it's a bit difficult. Maybe 6 months, maybe? They go, no, that's too expensive. It's not worth it. We'll have to go and think of something else. And that transformed into, I've got this great idea, can we do it? And they go, well, why do you want that? I don't understand. You haven't explained it to me.
And what about if we did that? If we did that, then would that, that little bit there, then we could do that really quickly, but would that fix your problem? And this product, sometime after I left, this product manager was heard to say, talking to developers is a pain. Because every time you go and talk to them, they ask you all these awkward questions that you really can't answer. But it raised my game. And that to me is the gold. And that's where I'm going to stop. Thank you very much.